Hello guys, this is lesson 11 and I'm going to link a video down below if you really want to understand this. Trust me, once you watch it, it will all make sense. Even doing the practice examples I have for us in the video, it's really helpful. And I'm going to try to explain as much as I can, but I do recommend watching that video before because everything I do will make a little more sense. So let's go through this. I'm going to turn this around. And basically what I'm going to want to do is attach these two rings so that this oxygen is opposite from this oxygen. Okay. So to do that, I'm going to count my carbons 1, 2, 3, and then I'll have 1, 2, 3. So yeah, this is the way I'm going to attach it. I'm going to move this one up here, move this one here. If I did this the other way, then this would be too close to this one, but I want them opposite so it can be more stable. Next, I'm gonna zoom in a little bit, and what I'm gonna do is use my heterolytic function to grab this bond on this side so that this carbon attaches to this carbon. So I'm gonna grab the bond here. If I grabbed it over here, then that would mean that these two carbons are gonna attach, but I want this so I can make a 6-member ring. Now I'm gonna grab this bond, put it over here, and then I'm gonna grab one of these bonds and put it over here. I'm gonna hit arrange, fit, and we see that my oxygens are opposite of each other, and then my double bond ends up right next to my single bonded oxygen. That's exactly what I want to see. I'll go ahead and submit it. So basically in that video they talk about what a diene is and a dienophile. So the most important thing with this is recognizing which is which. There's a really good question on here that's a good example, and I'm trying to get to that one. Here it is, perfect. So if you watch that video, which please do, this would be our diene and this would be our dienophile. So this one wants to be here with this one. So I'm going to move this over and see, it's gonna form a bond here. And we're going to use our heterolytic function to then attach it. So remember, I'm grabbing from here because I want to attach this carbon. Okay, now I'm gonna move this bond and attach to this carbon. And then I'm gonna move this. So it's kind of just like a shift of electrons and introducing a new little molecule to the whole thing. So this is what we have at the end. And trust me, I don't do like the instructions justice. That video is just so, I usually don't like watching videos, but that was really good. Okay, so I have my Z conformation of 1-methoxybuta. And I think, yeah, so this is going to be my diene. This is going to be my dienophile. So I'm going to want to attach this to these. And then I want to keep my oxygens close on this one. I'm going to move this down, and I'm going to move this over here and roll it around a little bit. Okay, and now I'm going to start creating that ring. Let me resize it so I can see a little better of what I'm doing. And then I'm going to use my heterolytic function and grab from the top, attach it to this carbon, grab over here, and attach it to the carbon, grab right here, okay, no, yes, grab right here, and attach to the carbon. Hit arrange, and what we have at the end is this funky looking molecule, but I am going to move these around because I don't like it looking like that. It looks off to me. So I'm going to move the hydrogens so that they can both be in the same position. Let's see if that took, yeah. That looks way better. And then with the Z conformation, I haven't been really playing around with it much, but I want to pay attention to these H's because I feel like they would have something to do with it. And in my notes, they're opposite, so they're anti. So I'm going to keep it like this. when we do the E, we're going to have these syn. So I'm going to leave it. It looks good to me. Yeah. So this one I tried doing myself before watching that video that's on the bottom, and I was lost. After that video, it just all made sense. Okay, so again, we have our diene on the left side, and then we have our dienophile on the right side. Okay, I'm gonna move this. So I'm gonna keep these oxygens near each other again, and then I'm gonna use my heterolytic function. I'm gonna grab from the top. I'm gonna place it on this carbon. I'm gonna grab from here, place it on the carbon, and then I'm gonna grab one of these and place it on this carbon. Let's see if I did it right. Sometimes it can be a little confusing because you get lines everywhere, but take your time. And then again, I got that funky little thing over here, so I'm gonna go ahead and make it look nice by moving the hydrogens, kind of rearrange it a little bit. Okay, and this one, I'm just gonna wanna make sure that my hydrogens are syn. So I'm gonna move this one. Okay, I'm gonna move it to the top. Let's see if that moved it for us. Okay, I'm gonna leave it like that. So let's see if that worked itself out. Okay. So I haven't tried it any other way. I just show you guys the way I do it that works every time. So I don't really switch things up. Maybe I should to like tell you if it was right or wrong, but some of these take a while. Okay, so we have our diene over here and our dienophile over here. It doesn't matter where the oxygen goes because either way it's going to be in the same position when you count. So if you're counting from the right, it's going to be the same position. If you're counting from the left, it's going to be the same position. So I'm just going to go ahead and move this closer, and then I'll start moving everything else. So I'll move it from here because I want this carbon to attach here. See if I do this, that makes this carbon attach and it adds another methyl. And then it makes a 5-member ring, which we don't want. That's why we grab here. You can always fix it if you get that 5-member ring, but it makes things a little more complicated. Especially with knowing everywhere to go, so it's good just to keep it the right way. Okay, let's roll this around. And like I was saying, if you count from here, 1, 2. If you count from here, 1, 2, 3. Let's roll this around. 1, 2, 3, 1, 2. So it's in the same position. Either way, this one's a little easy. It's kind of like the one we did with, what was it? Buta 1,3-diene and ethene. Pretty simple. I think, okay, so this is going to be the hardest one, just to make sure that everything gets done right. But I will show you guys how to do it. So I'm going to roll this one around. That's going to be my diene. And then I'm going to roll this around, and this is going to be my dienophile. Okay, let me move it, not roll it. Okay, so the single bond, well, the single double bond is going to be my dienophile, and then this is going to be my diene. I'm going to resize it so I can see a little better and then center it. Okay, now I'm going to move this bond. I want to attach this carbon to this carbon. I'm going to move it over here, and then I'm going to move this one over here. I'm going to ignore these, and then I'm going to move this one over here. Now I'm going to arrange everything, and this is the part where we have to really pay attention. So everything looks good except for these two hydrogens. I want everything facing up. If this was in the back, I would go ahead and move it on the top, but it actually ended up in the right spot. So if this is down here, we're going to want to pick it up. If these hydrogens are faced in, we're going to want to face them out and up like this. Now my hydrogens over here, I'm going to want to try to pick up. So I'm going to move them, try to move them as best I can. It might be a little difficult, but if you just keep trying. Okay, so they both moved. So we see it kind of folds the molecule around, and that's exactly what we want. We want all our hydrogens facing up. We don't want any down. Usually when I do this, it either happens like these are facing down, which we just fixed. This one's facing down, which I just pull out until it's facing like this. Or this is the other way, so inverted, but I want it out like this. So it's kind of like a little bridge. And this is exactly what we want. So this should be good to go. This one will be the hardest one just because we're making sure that all the hydrogens are in the right place and this little bridge is in the right place as well. Okay, I believe that was it. I will link the video. I really highly recommend you watch that. It just helps you make sense of everything, and we're obviously going to go through it in class, so you might want to get familiar with it. But yeah, good luck, and I really hope you watch that video.